Welcome everyone, welcome back to my next video in the Object References series. This is part 4 and I'll be talking about phantom references. So what are phantom references? Like the other references that I've spoke about in the previous videos, phantom references were introduced in Java 2 in 1998. Phantom references are the least used of all references, and unlike other reference types, you must use a reference queue. So in the other reference types, it was optional. You could declare and define a weak reference, a soft reference, with or without a reference queue. But here for phantom references, we have to provide a reference queue, and the reason why will become clear soon. And when you call the get method on this reference type, we don't actually return a strong reference to the object. Actually, it always returns null. And you can find more information on the phantom references in general from the Java docs at this URL. When the GC, the garbage collector, sees that an object only has a phantom reference, what it does is it actually calls the finalize method on the object, and then it places it in its associated queue. And it's interesting that the reference itself, the object isn't garbage collected yet, because for that to happen, the reference has to be cleared and or the reference is unreachable. So it's interesting there that it's quite different to the other references, where you have to actually manually clear the reference, because the garbage collector won't reclaim that memory until the program has cleared the reference or it's unreachable. Well, I suppose after talking about that, the next question is, well, why would you want to use phantom references at all? And the strong use case, or the common use case actually, is it's a simpler and less expensive alternative to finalizers, where finalizers themselves, just as a short summary, I plan to do a separate video on finalizers, but in short, for finalizers, which is a finalize method on the object, well, the garbage collector needs to know about these objects that have finalizers. So in effect, it has to be registered with the garbage collector, and the garbage collector itself will have to call the finalize method on the object when there are no other references to that object. And of course, this means that the JVM itself will hold a reference to that object, which slows down how soon that object will be released to memory. And also, it looks like the finalizers themselves will no longer be used in future versions of Java. In fact, in Java 9, it's been deprecated. But as I said, I'll be explaining finalizers more in detail in a separate video. So I think it'll be a good time now to move to a demo where we'll show the usage of phantom references and also the effect of different operations on the actual objects themselves. Here we are, we have our demo set up for today's demonstration on phantom references. So I'll spend some time just going through the code and showing you what I'm trying to achieve. So first of all, you'll see here that I have a customer class, which is a very basic class here. You can see it here, where it has a finalize method that says that the final has been called, and then it calls a super on that the super finalize method, the parent finalize method afterwards. That's the customer class, nothing exciting there. And then I create an array list of finalized customer references. And if you just scroll down here, you'll see the finalized customer reference itself is an extends phantom reference for the customer object. And I have the constructor and a little cleanup message here to show that we're going to try and clean it up at some point once there are no more references to these customer objects. So coming back to the main code, so here we have, as I said, we've got an array list here of finalized customer references, which are in fact phantom references, and an array list of customer objects as well. In the first instance, I'm going to add 5 elements to the array list and 5 those of the customer object, and then I'll use that reference to those objects and create 5 phantom references that I'll store in the corresponding array list for those as well. So as I mentioned here in the comments, after this we'll have, I started with 10, but I thought it'd be easier with 5. So I just update the comment there. So you have 5 strong references to the customer object and 5 phantom references to the customer object in memory. So then I'll call, just to prove what's happening, I'll call the GC and we'll see if any of the phantom references are in its queue. Oh yes, I had to mention the queue. Did I mention the queue early on? Yes, here's the reference customer queue, and I use that here in the constructor. So once we have, as we have the queue there, and we have strong references and phantom references, then I'll loop through and just check if it's been enqueued, if it's been put in its queue. And that should only happen if there are no other references to those customer objects. So in this case, I expect this to return false. And then what I'll do is I'll set the array to null. This array now is the array list, the customer array list here is null, which means that the array list to those customer objects is no longer referenced, and by extension then the customer objects themselves are no longer referenced. So that's why I mentioned here in the comment, after this line of code there should be no strong references to those 5 customer objects. Also, we would expect that the 5 customer objects are now put in the reference queue because there's only phantom references. So this is what we'd expect. Let's see what happens. Let's see what happens here. So we'll set the customer array to null in the, I'll print that out, and then I'll call again the GC, and then we'll check again if it's been queued. I'll sleep the thread for about a second, and I'll repeat that again. And I'll explain a bit later why I'm doing that, but let's just run with this for now. And finally, we poll the queue, and then we clean up and we clear the reference itself, which means that this is all going to be at the very end here, no objects left in the queue and no more references to the customer objects. Assumption is here that at some point either here or here, it's been put in the queue. So let's run this and see the output. And let's see now. So first call to GC, is there any object in the reference queue? It returns false. So this is this one here. So all this returns false. So we just get back to the console again. Does it return false? Yes. So you have all these are in false as we expect because there's strong references. So now we set it to null and we make a second call to the GC, but you'll notice now, and this is where it gets interesting, that you'll see a message here saying finalize called, and then you get 5 falses, which also says to us, tells us that it still hasn't been put into the queue, and then we get some more finalized calls. You'll notice there, and these finalized calls are from this message down here. So what we do know is that because we've set it to null, there are no more references, no more strong references. The garbage collector runs, it sees that there's only phantom references and it is calling the finalize, but it hasn't put it in the queue yet. And why is that? Well, you might recall in the earlier slides I mentioned that when you have a finalize method, the JVM effectively has a reference to that object. And a reference to the object is not a phantom reference, so it's an extra reference, and this is why the phantom reference, the object has not been enqueued into that reference queue because of the reference between the JVM and the object itself. And this is why you have your finalize call output here, and all these are returning false. That means it hasn't been enqueued yet. So then we wait for a second at our thread here, thread sleep method, and then we call the garbage collector again, and here we don't expect any more finalized methods to be called because they've already been called and it's only called once. And when we check for the queue now, sure enough, it's all enqueued. They're all true now. And once that's true, then we can call, we know it's true, so then when we poll, we'll get the references, we'll get the reference to each of those objects that are in the queue. We can call the cleanup method, and then we can clear it. So interesting, very interesting. I think this demo, I hope it's showing you what is actually going on under the hood, and I hope that this will help clear up a bit any misunderstandings between what a phantom reference actually is used for.